Hi everyone, I'm excited to share our latest work entitled From Exploration to End of Life, Unpacking Sustainability in Physicalization Practices. So my name is Panagiotidou and I'm an assistant professor at King's College London in the UK. And this work was in collaboration with Luiz Morais, who you will meet later in the presentation, Sarah Hayes, Tatiana Losev, Rebecca Noonan and Uta Hinrichs. So throughout history, humans have employed data physicalizations as a means of conveying information. From the Mesopotamian clay tokens dating back to 5,500 years before the Common Era to the intricate Inca quipus in ancient South America, extending to the contemporary manifestations such as art exhibitions and participatory studies. Over the last decades, the data physicalization community has generated more and more physical artifacts. Meanwhile, the planet shows signs that current human practices endanger the future of humans and non-humans. The debates surrounding sustainability in interaction design and HCI emerged in the 2000s. So SIGCHI 2007 spotlighted two influential works urging sustainable practices in HCI. In 2010, the term sustainable HCI was coined as an attempt to outline the new subfield and as an attempt to raise concerns about the excessive focus until then on persuasive technologies. Recently, scholars have even revisited the literature of sustainable HCI and are discussing the possibility that HCI research in general has little impact on sustainability. Data physicalization researchers have also recently begun to discuss sustainability. In the SIGCHI 2023 workshop of Physicalization from Theory to Practice, researchers have proposed several initiatives to consider sustainability of physicalization practices. At TAY 2024, scholars use data physicalizations as a way to spark conversations about the environmental sustainability of the conference itself. Nevertheless, despite those initiatives, no comprehensive work has explored ways of promoting sustainability in physicalization practices, and this is where our work contributes. In this work, we propose the field of sustainable data physicalization, which lies at the intersections of sustainability, data physicalization, and sustainable HCI. We consider SDP, the short of Sustainable Data Physicalization, as a broad discipline that encompasses research focusing on using data physicalization to raise awareness about environmental issues, as well as research that advocates for sustainability within the physicalization practice. So similarly to Sustainable HCI, this discipline seems to understand and deal with the impact of technology on the environment. However, SDP in particular focuses on sustainability concerns as they relate to the data, from the transformation to the data into physical representation. So that's actually the key point here. So in this work contributes into sustainable data physicalization in multiple ways. First, it introduces the physicalization life cycle, which serves as a framework to outline key phases in the lifespan of a physicalization. Then it outlines sustainability challenges and strategies based on participants' experiences. It characterizes sustainability dimensions for physicalization practice, drawn from our findings, experiences, as well as literature. And finally, it issues a call to action by proposing the Sustainable Physicalization Practices Matrix, the SuPPra matrix, that consists of prompting questions related to sustainability across the different dimensions and life cycle of physicalization. So to explore the different physicalization practices and how they're aligned with environmental sustainability, we conducted interviews and ran a survey with experts. First, we interviewed 8 participants about one of their projects involving physicalizations and asked them how they address sustainability throughout the different stages of the life cycle of that physicalization. Then, in order to widen the spectrum of participants, we also ran a survey with 12 more participants where we asked them similar questions. We analyzed both the interviews and the survey using thematic analysis.
One of the findings from the analysis was the life cycle of physicalizations. This life cycle comprises 5 stages that constitute the lifespan of a physicalization. The first step for conceiving a physicalization usually consists of gathering information on the topic, space, and other sources of inspiration. Then comes the ideation, where the designer creates the first sketches, selects possible materials, and establishes design constraints. When the concept is ready, the physical artifact is built and tested until it is usable. This is the creation phase. In the presentation phase, the physicalizations need to be transported, installed, sometimes exhibited, and documented. Finally, there is a stage in the life cycle of a physicalization that is little acknowledged, its end of life. At this stage, the physicalization owner needs to decide how to deal with the physicalization when it is no longer needed. Our study identified sustainability challenges that designers can face throughout the life cycle of their physicalizations. Creating sustainable physicalizations might be costly. Finding the right materials to decrease the impact of physicalizations to the environment requires extra time and effort. Also, some sorts of materials are more expensive than their unsustainable counterparts. Designers can also face issues related to material regulations and conflicts with project contractors, which can deter more sustainable practices. It is also a challenge to find materials that effectively encode the data while making the physicalization aesthetically pleasing and sustainable. Fancy materials like acrylic or steel, for example, makes visualization aesthetically pleasing, but might be a problem in the end of the physicalization's life cycle because they cannot be easily discarded. When the physicalization is done, transporting it can also be challenging, especially when the physicalization is built miles away from where it is supposed to be presented. Another challenge that is fundamentally inherent to physicalizations is dealing with data changes and how it can affect the entire project, causing waste of prototypes and time. Finally, a designer needs to reflect on how long the physicalizations need to last before being discarded. For example, what materials should be used for ephemeral physicalizations? Or in what circumstances a physicalization should be made of long-lasting materials? This work is not supposed to be exhaustive, so other challenges might exist. Our study also identified strategies that participants use to promote sustainability in their projects. To ensure the creation of a more sustainable physicalization, it is important to integrate sustainability aspects right from the project's beginning. It involves decisions like considering materials consistent with the data, the intended audience, and how long the physicalization is supposed to last. This choice of materials is also a central decision for a physicalization design. If the physicalization is designed to have a short lifespan, the designer should consider materials that can easily degrade. Another strategy is creating physicalization artifacts made of existing materials or making the physicalization modular so that it can be repurposed. Being sustainable means that designers need to consider alternative materials that sometimes are neglected because they are considered as waste, or considering practices that avoid the production of waste. Another aspect that must be thought through is how to transport and present the physicalization. Using found materials might avoid transportation, for example. Finally, the designer needs to be concerned of how the physicalization will be discarded and deciding or negotiating in advance how this process will proceed to avoid waste. In summary, a designer must be thoughtful of every phase in a physicalization's life cycle in order to avoid unsustainable outcomes. Inspired by the challenges and strategies from our study, we proposed 10 dimensions that designers need to consider in order to ensure more sustainable physicalization practices. Combined with that, we proposed the SuPPra matrix, a set of questions aimed at helping designers reflect on sustainability throughout their physicalization practices. The first 4 dimensions refer to the designer's intent of embedding sustainability considerations into their practice. Anticipation relates to the attention a designer pays to integrating sustainability into their strategy and choices for a physicalization prior to initiating the project. Negotiation reflects the management of tensions and contradictions associated with designing sustainably in order to reach an agreement between stakeholders that prioritizes a minimal environmental impact while meeting project requirements. Inspection is the process required to evaluate the sustainability of a physicalization project at each life cycle stage. Finally, reflection refers to the process required to continuously re-examine, reimagine, and improve the sustainability of one's physicalization practices. In the SuPPra matrix, we generated questions related to each dimension across all life cycle stages. In the exploration phase, for example, physicalization designers need to understand who are the stakeholders with power to decide about the materials and practices used in the project, and how to negotiate with them more sustainable alternatives. The other dimensions relate to the design choices that a designer needs to consider in order to foster sustainability in their project. Materiality encompasses the considerations regarding the sustainability of materials and how to avoid waste during a physicalization life cycle. Longevity relates to the factors influencing how long a physicalization persists, including the lifespan of the materials used, the rate and amount of degradation caused by usage, and the overall fragility or durability of the artifact. Versatility refers to the availability of and ability of the physicalization and its constituent components to be reused for other purposes. For example, to be used within other artifacts or to represent different data. Consistency asks how the materials, tools, and production methods chosen by the designer relate to the topic or the data being represented. Visibility is the extent to which data physicalization reaches its intended audience, either through first-hand encounters or its dissemination through documentation. Finally, viability is the practical considerations that a designer needs to contend with in creating a data physicalization. For example, budget, access to materials or equipment, availability of skills and expertise. We also created questions related to all of those dimensions in relation to different stages of the physicalization life cycle. One example is asking where and how the physicalization component will be dealt at the end of its life cycle. Please read the paper to explore more questions from the SuPPra matrix or to get inspiration to propose your own questions. So let's recap our contributions. First, we introduced the new subfield of sustainable data physicalization. As an outcome from our study, we categorized the life cycle of physicalizations and identified challenges and strategies for promoting more sustainable physicalization practices. Lastly, we proposed the sustainability dimensions and the SuPPra matrix as the theoretical and practical tool to support the consideration of sustainability while dealing with physicalizations. This paper invites other researchers and practitioners to use our matrix as inspiration to create more sustainable practices. We acknowledge that the findings from our study reflect our experience from our participants. Even though we try to select participants from different backgrounds, we cannot ensure that the list of challenges and strategies presented in this work is exhaustive. Similarly, the SuPPra matrix is based on the experience from our participants and our own. Therefore, the questions that we generated might not fit all the context. We would love to see other initiatives that explore the life cycle and dimensions in different fields and expand those theoretical frameworks. Thank you for watching. We hope that this presentation can inspire you to reflect on your design and research practices to make them more sustainable. If you want to know more about our findings, please read our paper.